All right, so taking a look at, so 144, 145, we just passed in. But then on page 146 and 147, is everyone good with the front page on 146? That was 1 through 9. Any of 1 through 9? Go ahead back there.
Me?
Yes.
Can you do 2?
Number 2 on page 146?
Oh, yeah.
Okay. All right. Shh. Number 2 on page 146. A little too noisy. We're getting there. We're getting there.
Miss, I thought you said only 1 through 6.
On
1 for the 6.
Oh, I had to sign the rest of it, but if we need to, we can go through them.
Oh, sorry. I'll
You'll get. I'm not worried. I didn't put any marks on it, so we'll be set. All right. Problem number 2. We know that x is equal to y. So anything that y might equal, x equals, and vice versa. Whatever x equals, y equal. So I could take this right here and plug it in right there. So that gives me 2y equals y plus 3. Is that okay? I'm going to subtract y, so then I get y is equal to 3. And so if y is 3, we know that x equals y, so x has to be 3 as well. All right, anything else from page 146, 1 through 9 that you want to see? Yeah? 1? Page 146, number 1. We know that we have this, and we know we have this. So y is equal to 2 separate things. So I can take this and set them equal to each other because they're both equal to y. See, add 2x, so I get 8x over here. Add 4, so I get 32 over here. Divide by 8, so I have x equals 4. That's my x value. So if I can take my x value, plug it in either here or here, doesn't matter. I'll just plug it here, so I get negative 2 times 4 plus 28. That's negative 8 plus 28. So that'd be 20. Any other questions on that? Yeah?
I'm kind of confused about how you have a line when you're only given 1 point.
Oh. That's the point that the 2 lines intersect at. So they cross each other, and that's the solution.
And those are the 2. Okay, yeah.
Yeah, those would be the 2 equations. So 6x plus 4 is like this, and then this one goes like that, and they happen to intersect there. Okay. Yeah. Yeah. Excuse me. Number 6 on page 146.
You just did that.
I just did number 6?
Yeah. No, you did number 6. You did number 2.
I did 2.
I thought you did 6.
No, 2. All right. So page 146, number 6. All right, so the second equation says that y is equal to this. So I'm going to take this whole part right here, and I'm going to plug it in right here. Okay, so I have 7x minus 8. There was a y there, but now I'm going to put negative 2x plus 9 in. And that's equal to 112. Does everyone agree with that substitution?
Yeah.
Okay. I'm going to distribute negative 8 over the parentheses. So I get that. And then we're going to add 7 and 16 together. That's 23x. I'm going to add 72 to the other side. 72 was that? 184. And then divide both sides by 23. So we'll find that x is equal to 8. Is that right? Yes. Okay, so we have our our x value being 8. So being I know that, I can plug in right there, or I can plug in right there, but the second equation is more set up for us because it's y equals. So that's 8, let's see, y equals negative 16 plus 9, which gives me negative 7. That's where those two lines would cross each other. Anything else on that front page of page 146? Okay. Yeah. I'm sorry? 9? Number 9, they want us to graph it. So you have y equals 3x minus 1. The other one, I have 2x minus 3y equals 10. Ew, this might not work nicely. All right, so let's create an xy axis. All right, so this equation we'll do in red. So I have negative 1. I'm going to go up 3. 1, 2, 3, right 1. So I get that. By trying to do the cover method on this one, I could be kind of successful. So if I cover up my x value, 2 times 5 would be 10. I have 1, 2, 3, 4, 5. And then if I cover up that, I get negative 3 times y equals 10. So y equals negative 3 and a third. So 1, 2, 3, and a third is like here. So that's our intersection right there. Negative 1, negative 4 maybe.
On those, would we have, on the quiz tomorrow, would we have to be exact, or do we just need to clarify where?
It'll be in a way that we'd be able to find it pretty easily. So, all right, can I flip the page?
Yep.
Let's go to everyone's favorite thing, the word problem. Suppose, yeah?
Oh, I was gonna see if you see.
Yeah, I'm going to do all the way through. Is that okay? Do the whole thing? Okay, suppose you want to join a gym. Colorado Athletic Club charges an initial $480 plus $40 per month. 24-hour fitness charges no initial but $55 per month. Write an equation for the cost of C, or for the Colorado Athletic. Okay, so this is on page 147. This is number 10. So the Colorado Athletic Club, their cost is $40 per month plus $480 that you have to pay. Okay, and then the other one is 24-hour fitness. They charge you just a flat rate of $55 per month with no setup fee. I don't know if this is true or not. They're just making this up. Okay, so write an equation for C. We have that. So letter A is the blue. Letter B is the red. How many months would you have to join for the price to be the same? Okay? So these are our linear equations. I could manipulate this to give me y equals 40x plus 480. That way we're dealing with x and y's. And I can manipulate this one to give me y equals 55x. All I did is I just changed the c and the m for cost and for months to x and y. That's the same thing. So then if we wanted to solve it for the months, so that's our x value, I could set this and this equal to each other. Right? And that was just substitution. Subtract 40, so I get a 15x over here. It's 480. And divide both sides by 15. Oh, anyone got a calculator out? 480 divided by 15. Help me out, please.
23.
Is it 23? Oh.
It's 30.
Oh, you said it backwards. That's awesome. 32 months. So once you get to 32 months, which with whatever membership, that means that you've spent the same amount of money. Okay, so with the blue one, you had to give them $480 up front, and then you had to pay $40 a month. With the red one, you just had to pay $55 a month. So sometimes people might look at the red one saying, "Hey, that's a little bit better." Well, once you're 32 months in, you have now spent the exact same amount of money. And then what would be the better deal over 3 periods, or 3-year period? Okay, is 32 months, is that 3 years? Under. 36 months is 3 years, right? So which one would you think would be the better deal if you were going to be there for 36 months, the red or the blue? Yeah.
Well, the blue.
The blue is absolutely right. Okay?
$60.
It's an extra $60.
Yeah, for
Cool. So if you wanted to figure out how much each were, you would take 36 and plug it into M for the blue equation, and then you'd also plug it in for the red equation, and you're going to find the red equation cost you more in the long run. Okay, so page 146 and page 147 should be complete now. Make sure your name is on that, and please pass. We're not there yet. We'll get there. I'm just trying to go in a little bit in order. So let's pass up 146, 147.
Is my name on it though? Yeah. No, not that one. Second to last. Yeah, no. Oh, all right, there. All 146ers.
Anyone traveling out of town this week? Yeah, where you going?
Utah?
Utah? Where you going? You got family in Utah? You got a family? Hockey?
You don't have to be jumping.
Any other 146, 147? Oh, thank you.
Actually, we should have done Friendsgiving. That would have been fun.
Right here?
Do you know what that is? I think it was like yesterday or something. I don't know if it was like a set date or something. Yeah, let's make our own.
No, Eagles probably.
But my friends did it.
These Cowboys.
It was
No, they just played the rest.
They just played number one.
Who won?
Yeah. So it's basically like Thanksgiving, but with your friends instead of your usual.
Cowboys are playing somebody.
Yeah. Get food. We're gonna do Friendsgiving in my
Look at the Thursday football this week. Should be 2 games. Detroit probably is playing.
So you're not even allowed to be up there?
Bears?
The Vikings play the Lions,
Okay.
Packers play the Cowboys,
There we go.
and Giants play the Redskins.
Oh, yeah.
Anybody have this sweatshirt that I can use today?
Oh,
It's kinda chilly.
that's it.
That's it.
The Giants are like 1-0.
They won yesterday. They shocked Chiefs. Yeah, they shocked the Chiefs.
I said, are you eating a salad?
Oh,
Winning.
yeah.
Jeffrey?
All right.
Oh, you.
All right, so let's take a look at page 148. That was the newest one. And that was talking about our elimination method, or sometimes known as the addition method. Agree? Okay, so let's just take a look at 1 through 9. I think I'd worked, what did we do last time?
1, 2,
You
and
said
3.
1 through 8.
Okay, great. So let's look through it 1 through 9 and we'll be okay. Anything on 1 through 9 you want to take a look at?
1 through 9. Let's see.
Just do
Right. I mean, no.
5. I'll do 5. All right, number 5. So we remember on these, we need to get opposite x or y values. Okay? Okay, so item number 1 and number 5. Do we have opposite values on x or y? Exact opposite. No. Now the next key on this sometimes is, do you have a positive and a negative of any of the values?
Yes.
Yeah, the y values are opposite value, or one's positive, one's negative, right?
Yeah.
So sometimes that might be a good place to start. Doesn't always happen that way, but it might just be a good rule of thumb. So what I'm going to do is I want to get those to be opposite values. So what's the smallest number that both 4 and 6 go into? 5?
12.
12 is right.
Oh, I did.
Build that book.
Alright, so 12 is the smallest number that they both go into. So I'm going to multiply this by 3 and this by 2. So if I distribute 3 here, here, and here, this equation now modifies to 9x plus 12y equals 33. Get in there, 33. And then this equation, I'm going to distribute the 2 here and here and here. So I get 10x minus 12y equals 62. Does that seem to be okay?
Yes.
Does everyone feel that if I were to add these two equations together, one of the letters goes bye-bye?
Yeah.
Yeah, I have positive 12y and negative 12y, right? So if I add these together, I get 19x. Y's are gone now, is equal to, that was 33, right?
Yeah,
What was that?
33 plus 69.
So that's 95. So if I divide each side by 19, I find that x equals 5. Right?
Yeah.
So we don't have y yet, so we have 5 comma, let's figure out our y value. So I'm going to take that 5, I'm going to take this 5, I'm going to plug it in either here or here. Doesn't really matter, so I'll just take the top one. So I'm going to get 3 times, that had been an x, but I'm putting a 5 in, plus 4y equals 11. So that's what, 15 plus 4y equals 11. Subtract the 15, so I get 4y equals negative 4. So what's y equal to? Negative 1, thank you. There we go.
Wait a minute.
Yes, sir. Any other problems on 1 through 9? Yeah. 4? Okay. I just make sure good. Everyone else good? Number 4. All right, problem number 4. I have 4x plus 2y, and that's equal to 0. And then I have 2x plus y is equal to 5. So just look it up there. If I add the equations together, do I have opposite x or y values? No. Do I have one value that's positive and one that's negative? No. Okay. Last thing is, would you like to get rid of x or y? So you have to pick one or the other. So I picked to get rid of x. So let's get rid of x. So do I need to multiply the top equation by anything, or do I just need to multiply the second one, right? So what would I multiply this second equation by to give me opposite x values? 2. So if I make it just positive 2, I have 2 times 2, that's 4x and 4x. So if I want to make it opposite though, negative 2, right? So I'm going to multiply by negative 2 here, here, and here. So the top equation stays as is for right now. And then the bottom equation looks like, excuse me, negative 4x minus 2y is equal to negative 10. So if I add these together, those cancel, so I get 0 equals negative 10. What does that mean? No solution. Perfect. These lines would have been parallel lines. There's not a solution. They're not going to cross each other. Good deal. Yeah. 8. All right. Oh, didn't want a graphing one too? Cool. Number 8 and then number 10. Number 8, we have 4x minus 3y is equal to 12. And then negative 12x plus 9y equals negative 36. Okay, so right now if we add these equations together, does an x or a y value fall out? The answer is no. So then we have to say, okay, what do we want to get rid of, x or y? So let's choose to get rid of y. So I'm going to multiply this whole top equation by 3. So that distributes here and here and here. So that's going to give me, what, 12x minus 9y equals 36. And then this bottom equation, we don't modify it at all. And everything cancels. We get 0 equals 0. True or false? True. So what can you tell me about the solutions?
Infinite.
Infinite solutions. It's the exact same line. Lies on top of itself. And then Brandon wanted number 10, was it?
Yeah.
Okay. Gotta move forward? Yeah.
How can you tell if something's
No solution when you get, like on this last screen, we had 0 equals negative 10. That's totally false. 1 equals 1 infinite solutions. That's totally true. So if it's a true statement, no matter what number, no matter what numbers come down, if it becomes 1 number equals the exact same number, that's infinite solutions infinite solutions every time. If I get 1 number equals some other number, even if like 1 is like positive 5 equals negative 5, no solution.
So what about one solution? How can you find that?
One solution is where you just find the x and the y value, so it's a point. Okay? 10, right? Alright, number 10, I have y equals 1/3 x plus 2. And then the other one I get y equals 2/3x plus 5. Hey, question. Will these lines cross each other?
No.
Yes, why?
Because
Slopes are different. Good. Different slopes. They're close, but they're different. If they're different slopes, they have to cross each other, and that gives you the one solution, right? All right. So let's do this one. That's positive 2. So I go up 1, right 3. Try and drive as straight as possible. And then this one I'll do purplish. So that's 5, 1, 2, 3, 5, and then put that dot up 2, right 3. Ooh, man. So I plotted 5 right here, and then I went up 2, right 3. And then that's our intersection. I didn't have real straight lines, but I don't even know. Negative 6, 0 maybe? Maybe? Let's see if that works. Negative 6 comma 0. If I took negative 6, plugged it in there, I get negative 2 plus 2. Yep, that works. Plug it in there, that's, no, is that right or wrong?
Could it be negative 7?
No, I don't know.
It's -9, -1.
Negative 9, negative 1?
Yeah.
Cool. Yeah, if you have a better grid than mine, you're definitely going to see that it worked. Negative 9, negative 1. Okay. Yeah, sweet. Okay. Huh. All right. Yeah. Yep. Hey. Number 11. I have 3y plus 4x is equal to 3. And I have x plus 3y equals negative 6. Ew, boy. We want to graph these, huh? I guess the top one I could try and do the cover method. It's not going to be real pretty. Y equals 3, or excuse me, y equals 1. So I'll do this one in green. And then x equals 3/4. So that's like here. That's the first equation. All right, second equation, we'll do blue. If I cover that, x equals negative 6. If I cover that, I get y equals negative 2. So there's our solution. I don't know, maybe 3, negative 3. I don't know. Again, I didn't do mine perfect. Is it? Is that what it is?
Mhm.
Okay. Sweet. All right, let's go to the word problems on the back of that page. Number 12, you have 29 coins in your piggy bank that are all nickels and dimes. Okay? Value of the coins is $2.15. Let D equal number of dimes, N equal number of nickels. Write a system that represents this. Okay, so this is on page 149, number 12. Okay, so we have 29 coins in all our piggy bank that represent nickels and dimes. So you empty out your piggy bank, you make you note, oh look, they're all nickels and dimes, and I happen to have 29 coins in all. So there's not a money value with it. Okay? I know that I have a total of $2.15, right? So I have 0.05 nickels plus 0.10 dimes equals $2.15. Alright? So, not a big fan of having decimals in here. So what I'm going to do here is I'm just going to move the decimal. I'm going to switch this equation to 5n plus 10d equals 215. Basically what I did is I just multiplied that equation by 100. That way I didn't have to deal with a decimal. All right. So I need to choose between here and here what I could do. I think I would like to get rid of dimes. The reason I'm choosing dimes is because if I multiply that total top equation by -10, the dimes were 10 cents, right? If I multiply the whole top equation by -10, something good might happen. So I'm going to multiply this whole thing by -10. I'm going to distribute that over, and I'll bring this down here. So -10 times n, -10n, minus 10d equals -290. So if I add these two equations together now, I'm going to get -5n, and those cancel, equals -75. Right? Yeah, -75. So negative divided by negative is a positive, so 75 divided by 5 is 15?
Yeah.
So I have 15 nickels. How many total coins did I start with? 29 of them, right? So if I have 29 total coins that were nickels and dimes, and I just realized I had 15 of them that were nickels, and that gives me 15 plus D equals 29. Subtract 15, so I got 14 dimes. 14 dimes, 15 nickels, to give me a whopping $2.15. Huh. Let's not worry about the challenge one. I don't want to strain your brain too much. All right, so perfect. We are going to skip. We're going to skip page 150, 151. So don't do it. You already did it. Well, it shouldn't break yet. But we are going to do 152, 153. So for the rest of the period, please work on page 152, 153, which is a review. We do have a quiz tomorrow. on this, okay? So that's what I'd like you to work on for the rest of the period, please.